Is everyone having a nice time at PHP UK so far? Cool. So today I'm going to talk to you about MVVM and Silex. So I'm Billie Thompson. You might recognize me from the picture. I cunningly wore the same t-shirt so that everyone will be able to tell. I'm a contracting software developer. I'm currently working with Sainsbury's, the lovely people who are sponsoring some of this event. And I've previously worked for lots of different companies, and throughout that time I've noticed several trends which are emerging in the software development industry, particularly to do with front-end development. And I'm going to talk about a few different things which are probably going to influence how you're going to write PHP in the future. Okay, so this is going to be a sort of demo-based talk. So I thought I'd better lay down the sort of general area where the demo is going to be from. So the domain is a bookshop. The subdomain is the bookshop's website, because it's pretty hard to write software for things which aren't digital. And the bounded context we're going to be working within is a book information service. And the book information service is just going to be a little website which lists us some details about books. Which is well exciting. And if you're not familiar with these terms, these are DDD terms. The domain is the overall area that your problem is happening in. The subdomain is a focused-in part of that, and the bounded context is an area in which you used ubiquitous language within. Just so you know where I'm coming from there. So this is what we're going to be building. You might have seen the slide up at the start, so you can open up code and stuff on your devices. The book jacket API is going to be a really small API which is going to return you the sort of information that you have on the front of a book. So like author, maybe a picture of the cover of the book, an ISBN number, probably a bit of a description. And the rating API is going to return us customer data. So users' ratings of the books, what their what the amount, what sort of thing they give it. Is it a 5 out of 10, 1 out of 10, 2 out of 10? And then we're going to pull this information together, and we're going to have a sort of integration layer, which is going to merge two API services and present us a custom API for a web browser, which is going to be running a full stack framework. And the integration layer is probably going to do a little bit of customization of code and making sure that the response that we send to the browser is specialized for the type of device that we're sending it to. Okay, so rather than rushing into this and declaring that we're going to be using Silex straight out, I thought it'd be better to lay down what the sort of requirements for each service are. So our backend servers, we need to choose frameworks and languages which are good, solid choices for backend servers. So solid for database interactions, solid for queues, and solid for business logic generally. So something that we're pretty familiar with, pretty comfortable with, and know that we can implement the business requirements in. For our middleware layer, we need to choose something which is capable of making lots of connections in parallel, and makes it easy to pull those together into a single response, rather than having to do things in a non-blocking manner. And because it's where our front-end website is going to be served from, we want to make sure that the front-end developers who are going to be working on their front-end code can easily work within it, so that we don't have lots of problems with context switching and all those problems that you get when you try and switch between two code bases which work in two slightly different ways. So the front-end, we're not just going to dump a load of JavaScript all over our website, so we want to use a framework which is going to make it easy for us to build a responsive website, so it's responsive to user interactions, and also extensible and clean, which is pretty basic requirements. Now, the frameworks which I think fit really well into this. So for the back end, I'm going to choose something that hopefully lots of us are very familiar with, and that is Silex. It's a really nice micro framework toolkit, and I'll talk a little bit more about that in a minute. For the backend, for the integration layer, I'm going to use a server-side JavaScript framework, and because JavaScript's non-blocking, that makes it really good for making lots of requests in parallel. And because it's in JavaScript, our front-end developers are probably going to be pretty comfortable working with that. So I'll run through a crash course in that. And for our front-end stack, I'm going to use AngularJS, because it's probably the most popular front-end framework which is out there. Okay, you've probably already seen this, but in case you haven't, feel free to open this up on your slides. Okay, so why am I talking about this? Now, the reason that I'm talking about JavaScript at a PHP conference is because of cross-functional teams. Now, previously, maybe 3 or 4 years ago, lots of us used to work in these heavily siloed environments where you had an ops team who didn't really integrate with the development team, the back-end team, and the front-end team maybe had their own little special unit as well, and the testers, they had their own little block, and we never the twain shall meet. And then occasionally you might sometimes, if you're lucky, get some input from product about what you should be making. So we decided that was probably a bad idea. And we switched to using cross-functional teams. Now, cross-functional teams have one of every single type in, one of every single flavor. We have a representative from product, hopefully. And we have some testers, we have some ops people, we have some developers, and we have some front-end people. And we all work really closely, and we spend a lot of time helping each other out with problems, and we are dedicated to fixing developing the feature we're supposed to be developing, rather than developing our tiny portion of the code. So we're really feature-focused. But this does have some downsides. It means that at some point, you might get to the situation where you, as a PHP developer, have to do some JavaScript. Maybe your front-end developer is off. Maybe they have a bit of a problem, and it's something in between the two APIs. So it's useful to have a bit of a grounding in JavaScript frameworks. And also, I think they're pretty darn cool. So that's why I'm going to be talking about these things today. So I've also structured my API around microservices. And this is because teams are, cross-functional teams are small and focused on the task at hand. They don't have 50 people in them because you can't easily focus 50 people on a single feature. We have maybe 9 people focusing on a single product, which means that we can only produce small things, but if we produce lots of small things and make them work together well, we get lots of opportunities for doing additional metrics and gaining additional utility out of our system from the get-go, which is fantastic. So dare I use the management bullshit term, synergy. Okay, so why JavaScript? So more specifically, why JavaScript now? So JavaScript's been around for a long time, and it's been sort of, it used to be kind of a sort of place where you'd do lots of code and then you'd sort of go and then you'd tack a bit of JavaScript on top of something else. And it never sort of like developed more than that. But then a few years ago, someone took the V8 engine out of Chrome and wrapped it up with some really useful server-side libraries and made Node.js. And from this really powerful tool, we started getting some really interesting tooling surrounding JavaScript. We started getting proper frameworks which allow us to do testing. One of the first out there was Backbone, and start to structure really nice projects. And along with these came things like package managers. So we've got NPM, which allows us to package things up and share them, which means people start caring about how their code looks a lot more because people are going to use it. And with this, obviously, came mature support tools like Grunt, which is a task runner and allows us to do loads of really cool things in JavaScript. So JavaScript is a really mature platform, and there's some really interesting things going on there. Okay. So by the end of this talk, I hope you have a working knowledge in on JavaScript on the server side. I hope you have a working knowledge of JavaScript on the client side, how to use a full stack framework. I hope you have an appreciation of how you might integrate those with PHP. I'm going to give you a few options of if you don't quite like my idea. And I hope by the end of this you can walk out and you can call yourself a cross-stack developer if you don't already call yourself that. Okay, so I'm going to start with Silex because it's PHP. We all love PHP. Do you love PHP? Okay, so if you're not familiar with Silex, here's a bit of a recap. It's a micro framework. It's built on Symfony components, so you know it's going to be rock solid and really good. And I'm hoping that lots of you have used it, so I won't spend loads of time on it. Right? Put your hand up if you've used Silex. Ah, there's loads of you. Brilliant. Okay, so getting started with Silex is dead easy, super easy peasy. Basically, all you need is Composer. You include it in your Composer file. Did everyone go to the, I hope everyone went to the Composer talk yesterday. That would tell you how to do that. And then you include autoloader from Composer into a single PHP file and then instantiate a single object. And that's basically how you get a Silex application up and running. So I'm going to show you this in a bit of a exciting demo. Hopefully it won't break. And I'm going to demo to you the book jacket API. So it's going to return you some information about a book. Okay. So if you want, you can actually hit this URL on your phone as well, and you should actually get the same thing back if you can't quite see it. So you can see it's just JSON for the book Crossover by Joel Shepherd. Really like that book, by the way. So all the books on here are from my top 10 list of books. And you can see there's a few things in there. There's an ISBN, there's a description, there's an author. It's pretty much everything that you need for a little application. And this is run by, like I said, basically 2 files. So here's the book jacket API. Don't worry if you can't see it. I'm going to show the code on the slide in a minute, so everyone will be able to actually read it. So we have a public index, and in there is some basic routing stuff, and we also have a controller, which I'll show you about in a minute. Okay, so I said that you needed 2 lines of code to start up a Silex application. That's all you need to start up the application. Just new up the Silex application and you're ready to go. By the way, if you look at the top of the thing, if you ever feel a little bit lost, in the comments in all the code of the slide I put which file it's running in, and I'll put the slides up online later on. Obviously, running Silex isn't very useful if you don't have any routes, if you don't return anything. So here's how to do a really basic route in Silex. This is your typical hello whatever example. So we've got get, hello, and then little curly brackets, which mean parameter. And then we've got a little lambda function that we're passing to it, and we're returning hello. And all this will do is return a string, which is hello. Which is okay, and it kind of works for this one little example, because it's only a really tiny example. But imagine if you had 10, 20 lines of code in there. I know controllers should only be 1 line, but it starts getting it's going to start getting a bit messy. So it'd be much better, and the much preferred way is to put these into controller objects. Now this is really easy with Silex. Now Silex is based off the dependency injection container Pimple, among other things. And this means that you can describe services that you're going to inject really, really easily. So you can see here we've got app share, and we're newing up the books controller. And you can see app books controller, so we've now defined that as a service, which is really cool. And then we've registered the service controller service provider, definitely not a mouthful, and we can now define routes which call methods on that controller. So we've got 2 down here at the moment. We've got slash, which is going to be index action, which is going to return as a list of book jackets. And we've got the ISBN, which is going to get as a specific book. Okay, so unlike other frameworks, you don't have to worry about mucking up your inheritance tree by extending a specific class to make a controller. You can just have a plain old object, and so long as it returns a Symfony response type, you're golden, basically. In this case, I've chosen to return JSON response. There's a few other response types which are predefined by Symfony, which you could also return here. But JSON response is obviously brilliant if you want to make a really quick API. Okay, so Silex is really cool for business logic. It's great for doing sort of rapid microservice development, and it works really well with familiar libraries like Doctrine, or again with just pretty much any Symfony-based project. It's only perfect for small services though, and as soon as we start doing more complicated things, we're going to find that developing glue to do things like write to Elasticsearch or write to queues and things soon starts getting quite tedious. So you might want to choose a different sort of approach to this. So one which was mentioned earlier on, I think in the previous slot, is API Agility, which is fantastic for making RESTful APIs. It's gets a nice wizard and can get you everything set up really, really quickly for CRUD operations. There's obviously Zen Framework 2 as well, and I think in the next session you could, there's someone's talking about, Sarah is talking about RESTful web services built easily with Symfony. So There's loads of stuff there if you're interested in that. Okay, so MVVM. What is MVVM? Since I titled the talk Silex and MVVM, talked about Silex. So MVVM is basically a front-end framework. It's a sort of catch-all term. They all implement this slightly differently in the same way that most MVC frameworks implement MVC slightly differently. The three main ones are AngularJS, Ember, and Backbone, sort of. So what is an MVVM framework? So an MVVM framework looks like this. It has a view, so you can think of the view as your HTML template on the page, and it has things like on it like a button that you could click, for example, as part of a long form. And when you click this button, because it's JavaScript, an event fires and goes up to the view model. And the view model turns this button clicked event into something a bit more complicated. It turns it into a new user created event, which is then passed to the model. And the model then persists that somehow, either in local storage or passes it up to an API, depending on what you need, which is not that dissimilar to sort of a standard MVC framework. However, there is one major difference. Because it's entirely event-based, we can actually push events the other way. So remote API can make a change to the model. The model can then notify the view model, and then the view can push those changes out onto the page without the user having to make any initial interaction to start the request, which I think is really cool. Okay, so why am I talking about AngularJS? Well, this is why I'm talking about AngularJS. It's the red line's AngularJS, in case you can't guess. It's really, really popular. Everyone's using it, so you should as well. And I will. Okay. So getting started with AngularJS is really easy. I won't show you this because initially when I wrote this talk, I had like 10 slides of me installing stuff into different environments, but it wasn't terribly exciting. So basically all you have to do is include some JavaScript files into your HTML template. I choose to pull these in using Bower. Bower is really similar to Composer, but for like front-end components, such as HTML boilerplate and things like that. It's got a real focus on UI components. You can also use NPM if you prefer. Okay, so now I'm going to show you the front end in AngularJS, and then I'll run through how that works code-wise. Okay, so this is it. This is the dream. This is the AngularJS application running in a little web browser. It's highly complex. It's got a total of 2 pages. So you can click onto the other page, and you can see like a little bit of a rating here, and you can see that the rating changes automatically depending on as users vote, which is pretty wild. Okay, so again, I'll just give you a quick tour of the code base in the IDE, and then I'll talk you through the code properly. So because this is all front-end, it pretty much all lives in the public. We have some JavaScript files in our JavaScript Angular directory, 3 app controller services, and we have some views, and only one of these is really relevant to our application, and that's index.jade. Now, I realize that you can't see that at all, so I'll flick back to the presentation, which you can see. Okay. So in case you're wondering, Jade is yet another templating language, but it's the default templating language of Express. And it's pretty easy to understand, so curly brackets means attributes, space means put stuff in the tag. And this is what it comes out with. I'm going to be mostly showing you stuff in Jade because it's a little bit shorter and fits on the slides a bit nicer. Okay, so there's 3 key files here that we're including from AngularJS. The first of those files is AngularJS itself, and then we're going to load in 2 additional modules. AngularJS is highly modular and based around dependency injection. So the 2 additional modules that I'm going to include is Angular Resource, which is a great little library for making RESTful APIs, API clients for AngularJS, and there's Angular Root, which is really good for making doing that multi-page setup that I showed you. Okay, and then there's the 3 files which I wrote in order to make that site work, and that's app, services, and controllers. And these roughly map to model, view model, which is controllers, and app, which sort of controls the view. It's not quite perfect. Okay, so one thing that you might have noticed from the template is there is a little thing in the HTML tag which maybe shouldn't be there, and that is the ng app tag. And you can see just below, so this is from the app.js, a similar sort of string here, which is books app. Now, AngularJS works on the basis of scopes. So you have an outer scope, and then within that you have narrower and narrower scopes. The first scope that we're going to define is the one for the entire application. And because I wanted to manage the entire page, I just stick it on the HTML tag. The other things that you can see here in the initialization of my AngularJS application is ng-resource and ng-root, which are the two additional modules that I mentioned that I wanted injected into the system, and the books service and the books controller, which are the other two modules that I defined for the system that are roughly analogous to model and view model. Okay, so a little bit further down this file, we've got the configuration for how we're going to route things within this application. So we've got a routes provider at the top inside a string, and then just below that we've got a little function which says $route provider. And what this does to AngularJS is it says, please inject me the route provider service into my function. And with this, we're going to define some routes. So you can see that each route has a couple of things. So we have, well, firstly, we have the route itself, which is /, and then we have a template URL. So AngularJS, like pretty much every other templating language, uses individual templates for each component, so you're not generating massive files, you only pull in the bits you need. And then just below that, we specify what the controller is that's going to manage this. And this is what's going to define where the data comes from. And then again, we have the same thing for ISBN, and at the bottom we have a redirects to. The reason, by the way, that we inject routes provider as a string and then have $routes provider just below it is in case we decide to minify the JavaScript. Obviously, the variable names will change, and it's so we can maintain a consistent way of tracking what should be injected into each function. Now, right at the bottom, you can see that from the index view again, the last thing in that file was a div with an ng view on. Now, this is where the content from these templates, when it's pulled in by AngularJS, is going to be put. Okay, so this is what one of those templates look like. This is what the index one, you know, that list of books. So we've got an index controller, it's got title, book list, and it's got this thing, ng repeat. So ng-repeat is sort of like a for each loop for AngularJS, and we have books in book. Books means like a set of books, and it's something that we pass into the scope, which is where we put our view parameters. And then we have book, which is obviously the single instance of it around the loop, and then we output it. And the thing which has ng-repeat in, it's an li, and it's going to be repeated every time we have a book. Okay, so this is what a controller looks like. This is where it's going to get the data. So we've got a module books controller at the top there, which is defined what this is the class which is going to be injected into our application when we define it in the first app.js. We've got an index controller which requires a couple of things, and it requires a scope and a book. So the scope is where we put things from the view, and that gets pushed out to the template. And every time we rebuild the scope, then we regenerate the view. And doing this sort of book query thing, because I've used a pre-built AngularJS application, a pre-built AngularJS module, it's going to rebuild the scope for me automatically. Okay. So this is how we define a web service really, really simply in AngularJS. It's what, like 5 lines? Which I think is pretty good for an API client, really. And so we specify book service, and we have factory for book, and then we request resource. Don't worry about timeout, I'll come on to that in a little bit. And we have API resource, and we're going to request a resource and say that ISBN is the ID, and this will provide us with an object which has a whole bunch of functions like query, get, that's about it really, and a couple of other things. Okay, so that basically gives us everything in order to do basically what an MVC application does and pass objects one way through a system. But what if we have additional data coming from the other side of the system? What if we want to push events in? So that's actually really easy. So you can do things like this. So I've defined an additional method on my book system, and it's going to push in changes to the scope via the callback here. And all is a simple method, and then on scope, on destroy, we'll stop requesting the page over and over again when we're finished with it. So I don't really have a long-time connection here, so it's just polling rather than doing a proper injection thing, but there we go. So pushing data to the API is actually really easy. So inside our model, we can extend with a couple of additional functionalities, a couple of additional methods. Here I've just done it so it polls, but obviously you can use long polling HTTP sessions, Flash, Kazing, or whatever fancy stuff you want to use, and just pull out the data. You'll notice that I'm calling API get. API get is a method which is part of ng resource, and it is what it's going to do is it's going to call global scope rebuild when we call the callback on this method, so we don't have to worry about the scope changing. If you were writing a function like this entirely from scratch, you'd have to trigger the scope to be rebuilt in this method. Okay, and that's just me canceling the property. Okay, so that's roughly AngularJS in about hopefully 15 minutes. So there's a few other alternatives to AngularJS if you don't want to use that. Yesterday, there was a really good talk on React.js. Now, React.js is a similar JavaScript framework, except it focuses on UI components in a tree-like structure rather than offering you a full MVVM environment. But that might be an option for you if you don't terribly like don't want to have to do the model way that AngularJS prescribes. There's also Backbone, which is sort of like a framework for making these things rather than a fully featured framework. And then there's Ember, which is AngularJS is sort of less popular cousin. Okay, so that's basically how we're going to start doing JavaScript development, front-end development in the future. It's definitely been a trend in the contracts that I've seen. More and more places are using these tools, and over time, I expect everyone will be in some form or another. So you're definitely going to come across this. But the good thing is that it's actually pretty simple. It's pretty analogous to how server-side programming works. It's pretty easy to understand. So if you do need to write some of this yourself or help out a front-end developer, then you're not going to have many problems. The key thing to note, though, is it does depend quite heavily on data from APIs. And with data from APIs, we don't really want to be exposing our entire API structure to the customer. We want to be able to shield ourselves from some of that request, maybe put some authentication or client rate limiting. And we can do this with a middleware layer. And for this middleware layer, I'm going to use Express, which has a freaking boring logo. It's just not even supposed to be upside down like that. It's supposed to go flat, but I thought it looked goofy. Okay. So this is the bit that I'm talking about now, the book info website. And less the bits which are serving AngularJS, more the APIs that AngularJS is calling. So the reason that I didn't go for PHP in this instance is I wanted to teach you about JavaScript. But secondly, PHP is a blocking language, so it's not really a terribly good fit for this, especially with its request lifecycle being the length of a request rather than longer. So it doesn't have any support really for asynchronousness. So you have to do methods in this pattern. So you have to get a book info website, you have to get a book jacket from the API, and then you have to go to the ratings API and pull in the data from there, and then combine that somehow to present the rating to the user. Which is like a lot of waiting around when we could be making the rating API call at the same time as the book jacket. Now, because Node.js is based around JavaScript and non-blocking callbacks, it makes it a really good choice for this sort of integration layer, because we can make these requests at the same time, we can pass the responses at the same time, we can handle errors and do retries without any issue. And also a really big consideration whenever you're choosing software for a particular component in your architecture is who's going to actually be doing the development work. So if PHP developers are going to be working on the front end and it's going to be PHP throughout, so that PHP might be a good idea then. But normally it's front end developers doing front end work on AngularJS. So it's a lot less context switching for them. If they need to fine tune this API, that they can just go in there and do it because it's in a language they're familiar with. And it's really, because we do it less often, we should take the cognitive overhead on switching between PHP and JavaScript. Okay, so that's enough talking. Well, clearly not. So here is how do you get started with Express. So npm install, npm is yet another package manager, and then you just output do Express to a directory, and it'll generate you a really nice, simple template. In case you're wondering, npm is more or less exactly the same as Composer. They all have little JSON files that you edit, and it uses semantic versioning everything. The only difference is its name's npm. Just a little sort of sidebar before I come on to talking about Express. Express is an application server, and application servers need restarting every time you make a change to the code, because in a von Neumann machine, we load the application into memory and then run it from memory. So you need to stop and start the machine every time that you make a change to the JavaScript. And a really cool way of doing this is with Grunt. It has a really cool, nice pre-written task called watch, which will allow you to do things when files change. You can use it for pre-processing your JavaScript and CSS, and you can also use it for like sending images to web servers and things. It's really nice. And the reason I say achieve Thing's dream is it always struck me that Thing always really wanted to be this central tool which people wrote tasks for, and then you never really had to write the tasks yourself. But no one really did that. A bit ahead of its time, perhaps. But Grunt's really managed to do this. There's hundreds and thousands of pre-made tasks on npm that you can install for this. Now, getting Grunt up and running is super easy. You just create a grunt file.json. Now, there's lots of text here, but don't worry about that, because the bits at the top are mostly just where is the bin file for Express. Now, the two bits that tell them that we want to load a task into Grunt is grunt.npm load tasks, and then we've just got to, then this will tell Grunt to load, in this case, contrib watch, which is something which will watch for changes in the file system, and grunt express server, which will start and stop our express server. And we can combine these tasks, the tasks that these features that we're including provide, into a single task. So here I'm combining, creating a task called server, which will start Express and then start watching for changes in the file system. And then when watch picks up more changes in the file system, it will restart the server. And I've defined it as default, so I can start the server as grunt. Okay, so here's a little demo of the APIs. So we've got this details page here, and this is powered off the API endpoint. And it's got a few things. It's got like a title, there's an author in there, there's a bit of a description, it's got a rating. So it's pulling in data from 2 different web services. I can also show you the index page, which is largely the same, but without the ratings. Cool, so that's basically what we're outputting from Express. So there's more or less, there's just one file really that you need to worry about with Express, and that is app.js. And that has pretty much everything in. There's also a couple of routes which have define things like controllers, basically. And I'll show you this properly in here. Okay, so inside our app.js, we're going to include these routes files. So we have routes index, which is the bits for our AngularJS application. And then we're including book API v1 and book API v2, and we're going to use them as routes a little bit further down. So what this does is it tells Express to mount API v1 in front of all of the URLs which are inside that routes file. So you can easily define a whole bunch of stuff in one go, which is what you can do with Composer, Silex as well. And you can see this other line here where I'm loading assets modules as the Bower components directory. So everything in that file will basically be public, which might not be a good idea. You might want to provision out your components, depends what you're pulling in with Bower. Okay, so routes. So inside our routes file, the routes index file, we do this thing where we do router get slash, and then we do res render index. And what this does is it goes and loads the index.jade file and returns it to the user as HTML. Nice and simple, right? And then we've got our nice AngularJS application. But our API, it does something a little bit different. So firstly, we have a root. Remember, this is mounted off /API v1 or v2. And we do res.json, and we return some books as a JSON client, as a JSON array. And the API client is actually really simple. So all it does is it makes a little HTTP request to the book jacket API after concatenating the ISBN on the end. So you can see here that AngularJS is Node.js is a really event-driven language. So we have res.onData. So this is the HTTP library of Node.js. And what we're doing here is we're waiting for some data to come in after we've made a HTTP call, and which we're doing at the top with the HTTP get URL. And we're going to add it onto the string every single time that it comes in. But what this means is every time that we're not blocking on I/O, every time that we're blocking on I/O, we can do other things. We can run other processes. We can make better utilization of the hardware which is inside our machine. And then you can see res.onEnd. When we've finished receiving all the data, we then pass it to from JSON into an API response, and we call the callback back that we passed in originally, which calls the to_JSON part of Express. And you can see the first parameter is null. There is a pattern in Node.js where you have a callback, and the first parameter is always the error, regardless of what's going to come in afterwards. So you can just say null, but it just makes it really easy to check if an error has occurred. Okay, so that's all well and good, but that doesn't really tell you how to tie two APIs together with Node.js, which is why I said that we should use Express to do two things at once, so it's really easy to call multiple services at the same time. I'll skip that bit. Okay, so we've got a router here, so we're going to get the ISBN. So this is what the router looks like for the book API v2. We're going to get the ISBN number. So we're going to visit, if someone visits the AngularJS, the API v2, and then passes a number afterwards, we're going to make two calls in parallel. And we're going to do this using Node.js's async library. It's a really common library. It's not part of core, but it probably should be. And it allows you to really simply do things like block and wait for multiple callbacks to finish until, so you can do things like make multiple API calls at once. Now I'm using it in like the most simple way. There's loads of other cool stuff in there, like you can limit the number of connections, the number of things you're doing in parallel to 10, and have it as like a queue system, so you have like 10 workers, and then just keep processing until they're all done. And at the bottom, once these APIs have called back and called the callback which is provided, then we're going to get another callback executed at the bottom. So we're going to make advantage of another common JavaScript library, and that's underscore. Has anyone used underscore here? Cool. So we're just going to use underscore extend. So if you're not familiar with extend, it's just like array merge, but for objects in JavaScript, which is really cool. Save you from writing it if you have to do that. Okay. So there are a few alternatives to using AngularJS, to using Express, and one of these is to use Guzzle with Express Futures. Obviously, you can't pass the responses at the same time as you can with JavaScript. However, it is like better than nothing. So if you've got a heavily PHP-focused development team, that might be a good choice. The other option, which had a really good talk about it, is using PHP with queues and making a sort of reactive environment rather than using REST, which is a really good option if you've got people who are comfortable using queues and you're ready to deal with things like cascading failures. And obviously, OK and Go are really good choices for any of the languages built in parallelization are really good choices for these. Okay, so that's Express. It's non-blocking, it's front-end developer friendly because it's JavaScript, and it's lightweight. You can get it up and running in no time, and it's super easy to get sort of complicated things done in it. So in conclusion, cross-functional teams require knowledge of other disciplines. You're going to be working closely with JavaScript developers, so it's important to know a little bit about what they're doing and maybe get excited about the same things that they get excited about. MVVM frameworks are going to be getting more and more popular. There's been at least one other JavaScript talk here, which I think is probably a record. And you're going to find them getting more and more popular. You're going to see them in your day-to-day life, and so you're going to need to know how they work. MVVM for applications use APIs and use the middleware layer to hide and customize your response on a per device basis to get the most out of them. Okay, so I've got a joined in link up there. If you loved it, hated it, leave me some feedback. Has anyone got any questions? Yeah. Oh, hang on. I think we need a microphone.
You seem to be using Express and Node. You switched as you were explaining the last set of code between saying Express and saying Node. Is Express just a subset of Node? Or?
Yes. No, so sorry, that was probably a little bit confusing. Express is a MVC-style framework written on top of Node.js. It's a JavaScript framework for the server side.
Okay.
Any other questions? Cool. I think we're done.